Last time we talked about the distance and midpoint formulas, and today we're going to relate that to circles. So first, let's go ahead and define what a circle is. I know that you all know that a circle is a shape such similar to that. Not a very good drawing of one, but you know what a circle is. Let's go ahead and think back to the geometry definition of a circle that you would have learned when you were in geometry class. So a circle is defined as the set of all points in a plane that are equidistant from a fixed point, which is the center. Equidistant means that they are all an equal distance from that center. And the radius is defined as the fixed distance from a circle's center to any point on the circle. So if we were to sketch this out, we would get, and we could put it in an x, y coordinate plane. I'm going to go ahead and just very roughly sketch that out. So we've got a circle in our plane, and somewhere approximately there we have the center. Now we can say that the center is at the point H, K, giving the location of the center an x and a y coordinate. And we can also say that if we took a line and connected it from the center to a point on the circle, that would also have a coordinate pair, an x and a y. And so what we see here is we see that we have a segment with two endpoints, hk at this end and xy at this end, and this looks very similar to what we did with the distance and midpoint formulas. Of course, at that point we didn't have the circle around it, but we were able to find the distance between the two endpoints, and we were able to find the midpoint. And so we're going to expand upon what we learned in that lesson in order to come up with the equation for a circle. And so if we take the distance, let me go ahead and write that out. We had the square root of, and depending on which points are used, we had x2 minus x1 plus squared plus y2 minus y1 squared, and that was equal to the distance. Okay, so now we're going to relate this to our circle here. So if we replace x1 and y1 with the location of the center of the circle, and we replace distance with radius, we get the square root of x minus h squared plus y minus k squared. We no longer need the 2's, the subscript 2's, because we only have one x and one y. And then that is equal to the radius of our circle. So we put the value of the x and y coordinates of the center in for h and in for k, and then we can come up with the radius on the other side of the equation. Squaring both sides gives us the standard form of the equation of a circle. So let's go ahead and add that to our notes. The standard form of the equation of a circle with the center hk and a radius is in the form of x minus h squared plus y minus k squared is equal to the radius squared. So if you're given the center point and the radius of a circle, you can come up with this equation. Also, given this equation, you can find the center point and the radius of a circle. So let's go ahead and try this out with some examples. Example 3 says, write the standard form for the equation of a circle with a center at 0, 0 and a radius of 2, and then graph the circle. So let's go ahead and see, did I put a graph on here? Let me see if I put a graph on here. Nope, I didn't. Okay, so we'll just have to sketch one out. Okay, so we have our center point at 0, 0 and the radius of 2. So we're going to go ahead and start with our generic circle equation. I'll go ahead and rewrite it on this page so that it's in front of you. X minus h squared plus y minus k squared is equal to the radius squared. So let's just go ahead and start plugging in. H and k represent the x and the y of our center, and r represents the value of the radius. So this becomes h minus 0 squared plus y minus 0 squared, which equals 2 squared. And this is in the general form, but we can simplify this. X minus 0 is just 0, so that becomes x squared. Y minus 0, 0, that becomes y squared. And 2 squared is equal to 4. So this is the equation in standard form of a circle with the center at 0, 0 and a radius of 2. Okay, now we're supposed to graph it. I'm going to very roughly sketch it out here. So we have 1, 2, 3, 1, 2, 3. This will be a lot better on graph paper, but I forgot to put in a graph paper image here. Okay, so we know that our center is at 0, 0, so we can put a little dot there to represent the center. And then we know that it has a radius of 2. That means from the center, it goes out 2 units in all directions. Now there's an infinite number of points that would be, but let's just use the easiest ones to calculate. We're going to go 2 to the left from the center, put a dot there, and 2 to the right of the center, put a dot there, 2 up from the center, and 2 down from the center. And then you will attempt to connect all 4 of those points with a circle. It's not perfect, but it's good enough. And so any point on this sketch should be exactly 2 units away from that center. And so that's how you write the standard equation and graph when you are given the center and the radius. So let's go ahead and try another one. Check point 3. So go ahead and pause the video and work this out on your own, and then come back and see if you did it correctly. So to set this up, I'm going to go ahead and write my generic equation first. X minus h squared plus y minus k squared equals r squared. And then I'm going to plug in my center points, ordered pairs, and my radius. X minus 0 squared plus 0. Y minus 0 squared is equal to 4 squared. And then we can simplify. X squared plus y squared is equal to 16. And this is the equation in standard form for this circle. And then if we were to plot that once again, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Not perfect, but good enough. 5. 1, 2, 3, 4. Ideally, all these would be spaced apart evenly, right? But we're going to make do with what we have. So we have the center point, and then our radius is 4. So we're going to go 4 each direction. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Connect those. Whoa, that's a horrible circle. And of course, sorry, it looks like the worst circle ever. Of course, because I didn't space out my grid evenly, it's not going to look great. But hopefully you can do this on some graph paper, and yours looks better. But it should be similar to that. Let's go ahead and do example 4. Now we have the same thing. We were given the center and the radius. The difference is that the center is not at 0, 0. So this one's going to be slightly more complicated. We are going to start with our generic equation again. X minus h squared plus y minus k squared is equal to the radius squared. So let's go ahead and start plugging in. X minus our x of the center is -2. Don't forget the negative there. Even though it's already minus, you still need the negative. Plus y minus, we have a 3 squared is equal to 4 squared. And then let's go ahead and simplify. X minus -2 simplifies to x plus 2 squared. And oops, I forgot the end parentheses here. The y is already simplified, y minus 3 squared, and then 4 squared is equal to 16. So this is the standard form equation for a circle with a center at -2, 3, and a radius of 4. So let's go ahead and do a checkpoint and see if you can do it before I go through it. So pause the video, work through it, and then come back. I'm going to go ahead and start by writing out the standard equation again. Hopefully eventually you'll memorize this and you won't need it, and it won't need to reference it. X minus h squared plus y minus k squared is equal to r squared. We'll plug in x minus 5 squared plus y minus -6 squared is equal to 10 squared. Simplify. X minus 5 squared plus y plus 6 squared is equal to 100. And this is the standard form equation for the circle with the center at 5, -6, and a radius of 10. So check your answer and make sure that you did all the steps correctly. If not, go back and rework it. So now we're going to move on to doing it the opposite way. You need to, given the equation, find the center and the radius. Okay, so it's opposite of what we just did in 2.8.3. So example 5 says find the center and radius of a circle whose equation is x minus 2 squared plus y plus 4 squared equals 9. Then we're going to graph it and then use the graph to identify the domain and range. So first we're going to find the center and the radius. The way we do this is we just identify the parts, right? Let me go ahead and rewrite our general equation up here. X minus h squared plus y minus k squared is equal to r squared. Okay, so we know that the x value of the center is h, the y value of the center is k, and the radius, of course, is r. So let's go ahead and change this equation that we were given into that form. X minus 2 squared is already in that format, but we have y plus 4. We want it in, for standard, we want it in minus. So let's change it to y minus. And in order to get that minus there, we need to change the positive 4 to a -4. Y minus -4 is equal to y plus 4. And then we're going to take the square root of 9 so we can get it into the r squared format. That would be 3 squared. So we have rewritten our given equation into the standard form there with the negatives and with the squares so that we can identify the pieces. So this is our h, this is our k, and this is our r. Therefore, we know that the center is at 2, -4. And we know that the radius is equal to 3 units. We don't know what units those are, but we have found the center and the radius. Now we need to graph the equation. So if my center is at 2, -4, it's going to be positive 2 on the x and negative 4 on the y. I'm going to go ahead and put my, ooh, that was horrible. Let's try this again. I'm going to put my xy axis in here. Hopefully yours looks a little better. And so the center is at positive 2, 1, 2, and negative 4, 1, 2, 3, 4. Put my center in there. And then the radius is 3, so I need to go each direction 3 units. I'm going to go up, down, left, and right 3 units. So let's go ahead and do that. 1, 2, 3. I know there's a point there. 1, 2, 3. There's one there. 1, 2, 3. There's one there. 1, 2, 3. There's one there. And then I would, as best as I could, and this would be a lot easier if I was doing it on paper, so please bear with me, but we're going to connect those points with a circle as best we can. There we go. So now we have graphed the equation, and then it says use the graph to identify the relations domain and range. And so looking at the graph and looking at the points that we plotted to get the graph, we can see that the domain, right? The domain is every value from -1 inclusive of -1 all the way to 1, 2, 3, 4, 5. So the domain is -1, 5. And the range is every value, start with the most negative, every value 1, 2, 3, 4, 5, 6, 7, -7 inclusive, all the way up to -1 inclusive. So that is how you find the domain and the range of a circle when you are given, well, from the graph, when you are given the equation. Let's go ahead and do a checkpoint on this to see if you are understanding it. Oops, too far. Let's go back. Checkpoint 5. Find the center and radius of a circle whose equation is x plus 3 squared plus y minus 1 squared is equal to 4. Graph the equation, and then use the graph to identify the relations domain and range. So you're doing the same thing on this one that we did on the previous one. Go ahead and pause the video, see if you can work it out on your own, and then come back and check to see if your answer matches mine. So let's go ahead, and I will go ahead and rewrite our formula here. X minus h squared plus y minus k squared is equal to r squared. Okay, so we're going to convert this given equation into that format. So x minus, to get that to be a minus, we have to change positive 3 to -3 squared plus y minus 1 is already in that format is equal to 4 is equal to 2 squared. So here's our h, here's our k, and here's our r. So that means the center is at -3, 1, and the radius is equal to 2 units. Then we'll go ahead and graph that, as I'm going to attempt to graph it here. Okay, so our center, let me switch colors here. Our center is at -3, 1, 2, 3, positive 1, and our radius is 2. So we're going to go 2 in each direction. 2 to the left, 2 to the right, 2 up, 2 down, and one thing I know, when it's easier when I have paper to do a circle, is to put all the little rounded parts here and then connect those. Oh, that one didn't turn out so well, but that might help you to get more of a circle shape than just trying to connect them all in sequence. Okay, so now that we've graphed that, we need to find the domain. So the domain, we look at our lowest x value, and we can use our center to find that, right? Our center and radius. If our center is at -3 and the radius is 2, the lowest x value is going to be -5 inclusive, and the highest x value is going to be -1 inclusive. So you can use the graph, or you can use the center and the radius to find the domain and the range. The range is going to be 2 subtracted from our center, which would be -1, and 2 added to our center, which would be +3. So check your answers, make sure you got the same ones I did. If not, go back and rewatch it or rework it. Okay, now we're going to talk about converting general form to standard form. Now this is probably going to be the most complicated for some of you, because what we have to do here is we have to complete the square in order to do this. We did this a while ago. If you need to go back and review that, you can find some Khan Academy videos on completing the square, or send me an email and I can send you a link to those. To write in standard form and graph x squared plus y squared plus 4x minus 6y minus 23 equals 0, the first thing we're going to do is we're going to move the constant over to the opposite side of the equal sign from everything else, and we're going to rearrange it so that all the x's are together and all the y's are together. So we would get x squared, and then we're going to move the 4x next to the x squared plus 4x. We want to get all the x's together, and then the y's plus y squared minus 6y, and we're moving the -23 to the other side by adding 23 to both sides. Okay, so we've moved the constant over and we've put the x's together and the y's together. Now we're going to group them with some parentheses here. Okay, right, because adding is commutative. It doesn't matter what order we do it in. Now we're going to set this up to complete the square. So we're going to do x squared plus 4x, and then we're going to leave some space because we're going to be adding something there to complete the square, plus y squared minus 6y, leave some space, is equal to 23. I'm running out of space here. Okay, is equal to 23. Now, if you remember back to adding the square, we always look at our b value. Remember, b is the coefficient that is attached to the x that is not squared. Okay, and so what we're going to do to each of these, we're going to add b divided by 2 squared. Okay, so for the first one, we have 4 as our coefficient here, as our b. So we're going to add 4 divided by 2 squared. 4 divided by 2 is 2, and that squared is equal to 4. So we're going to add 4. But remember, whatever we do to one side of the equation, we have to do to the other side. So I would normally do this linearly, but I'm running out of room here. And then we're going to do the same thing for the y's. Our b is -6. Because we're squaring, we can ignore that negative. So it's 6 divided by 2 squared, and that equals 3 squared, which is 9. So I'm going to add 9, and then I also have to add that to the other side of the equation. Okay, so I have x squared plus 4x plus 4 plus y squared minus 6y plus 9 is equal to 23 plus 4 plus 9. Now, because we completed the square on this, we know that this is a perfect square and this is a perfect square. So we're going to factor that out into x plus 2 squared plus y minus 3 squared, and then we're going to go ahead and add 23 plus 4 is 27 plus 9 is 36. Okay, and then we have just finished putting this into standard form. You'll recognize this from the previous exercises. Now, if you're confused about how to go from here to here, if you've successfully completed the square, if you did this correctly, then all you do is you put in your variable, and then you add half of your b, okay, which you already found up here. You don't square it though to add it, you just add half your b here. So here our b is 4, add half, which is 2. Here our b is -6, add half, which is -3. And that's how you complete the square. Okay, and then we need to graph this. And so we're going to use the information we got in order to graph it. We know that the center is at -2, 3, and the radius is 6, right? If we were to change this to negative, it would be -2, x minus -2. So that's where I got this -2. And then the radius is here, this is r squared. So the square root of 36 is 6. So let's go ahead and plot that. We're going to go, let's go here. Ooh, I'm not very good at drawing these axes here. Hopefully with time I'll get better. Okay, so our center is going to be at -2, 1, 2, +3, 1, 2, 3, and then I'm going to go 6 in each direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and I left just barely enough room there. Let's see if I can get it on there. 1, 2, 3, 4, 5, 6. Okay, and then that would be our circle. Let's see how well I can do a bigger one. It's harder to do bigger. Sorry guys. You know what that's supposed to look like. You know what a circle looks like. Okay, so we have written in standard form and graphed the circle defined by this equation. Let's go ahead and have you do a checkpoint to make sure you're understanding. Checkpoint 6, write in standard form and graph x squared plus y squared plus 4x minus 4y minus 1 is equal to 0. Go ahead and pause the video, and if you need to go through the last example as you do it to follow the step-by-steps, go ahead and do that and then come back and check your answer. So now that you've worked it out, let's go ahead and work it out together. So the first thing we're going to do is we're going to group the x's and the y's. We get x squared plus 4x plus y squared minus 4y, and then we're going to move the constant to the other side, so that equals 1. And then we're going to go ahead and add some parentheses in here to group them, and now we will complete the square. X squared plus 4x, I'll go ahead and leave space here, plus y squared minus 4y, leave some space, is equal to 1. Okay, so to the x's, I'm going to add 4 divided by 2 squared, which means I'm adding 4. To the y's, I'm going to add -4 divided by 2 squared. Because we're squaring, the negative doesn't really matter. We are also adding 4. But remember, whatever we add to this side of the equation, we have to add to this side. So I'm going to add 4 and another 4, because I added 4 here and I added 4 here. Now I'm going to factor these out because they are perfect squares. We know they will factor out if we have done them correctly. X, take half of b, plus 2 squared. Y, and half of b is -2 squared, is equal to 1 plus 4 is 9. So this tells us that our center is at -2, +2, and the radius is 3. Here's our equation in standard form, and there's the information that we got from that. So now we have enough information to graph this. Put my x and my y here, roughly, and the center is at -2, +2, and the radius is 3. So I'm going to go 3 each direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I'm going to try this method again, see if this one does better. It's just really hard to draw on the computer. Okay, there we go. So we have come up with the standard form equation and the graph of x squared plus y squared plus 4x minus 4y minus 1 equals 0. Go ahead and check Google Classroom for your assignment. If you need help, please don't hesitate to contact me. Also, rewatch the video or sections of the video if you need to.